Hello, my name is Ren, and today is Animation Day. Now if you remember in the last session, we created these simple pickups to damage and heal our player, and we said that our next session would be Animating Objects. So what we're going to do is we're going to animate this key to bob up and down and spin, so we know it's interactable. We're also going to animate the health bar to bounce a little. I've already started some changes to the key blueprint. So originally it was parented to a paper sprite, and one of the things we said about those was that we couldn't change the position and rotation of them. And what I've done is I've gone in there, I've gone to File, I've reparented the blueprint. And as you do that, it loses the sprite. So I created a scene root and a paper sprite inside there, and I kept the box collider where it was. So it's still got its function for when we interact with it. So now that we've got this root, box and paper sprite set up, what we can do is animate this paper sprite. And to do that, we're going to use a timeline. Once you've created that, we can name it, so we'll call it Spin and Bob. And what a timeline essentially does is it gives us control over curves of values. These values can be floats, they can be vectors, they can also have events being called off of them. We also have a color track. Now you might think that when we're changing rotation and position that we're going to use a vector, but because we're only moving up and down and we're only rotating in one direction, we're going to use two float tracks. Our first one is going to be for the rotation, and our second one is going to be for our position. Now at the top here, you'll see that there's a length. We're going to set this to 2 seconds, and our animation is going to happen within those 2 seconds. So on the rotation track, we'll add a key. We can set the time and the value at the top here. So at 0 seconds, we're going to have 0 rotation. At 2 seconds, we're going to have rotated 360 degrees. You'll notice that we couldn't see that change there. If we click on one of these zoom options, we can either zoom to the width or zoom to the height. You'll see that we can see that full graph now. Now this is a linear animation, which means that it's going to go all the way to the end, and if we played it again it would just carry on as if it were just a consistent animation. And as for the position, we're going to do it a little bit differently. We're going to have a nice curve. So at 0 seconds, position is going to be 0, and then at 1 second we're going to raise by about 50 units, and then at the very end we're going to bob back down at 2 seconds back to 0. You'll see this is still linear, and if we want to look at this timeline we can click the zoom function again. You'll see that it's changing both graphs. There's a synchronized view button on the left which will allow us to zoom independently of each other. One of the things we want to do on this graph is make sure that they're nice and curved. So if we select all of our keyframes, we right click that, we'll have a couple of options here. Now, automatic is going to create a nice Bezier curve for us, and that's what we kind of want. We want it to slowly move up into the air, sort of stop in mid-air, and then fall back down. And every time we call this function in this timeline, the update will run through that curve and output the variables using these 2 pins, which are based on our 2 curves. So to play that, we'll create a custom event called Play Animation. So we're always going to play this from the beginning, and we're going to play it every time it finishes. That way the animation will never stop. The next thing we need to do is make sure that on begin play, we're playing it from the beginning again. So we can either plug it into here, or we could call Play Animation. And in the update, this is where we want to change that paper sprite location. When we type in location, we'll see that there's a couple of options. Two main ones really are set relative and set world location. And this brings us back to why we create a scene root inside our hierarchy on the top left here. So if we use relative location, this will change the paper sprite relative to its parent, the root. So if we left this to 0, 10, 0, it's only going to move it 10 units upwards. Now if we did this same vector calculation to the world location, it would move this paper sprite all the way to the origin of the world, which might not be where our actor is. So that's the reason why we have the root, and that's why we're going to be using relative location. So in the update, we'll split that struct pin, and on the Z position, we'll be bouncing up and down. And the last thing we want to do here, change the relative rotation. So we'll split the struct pin on that again, and for the rotation we're going to be changing the yaw, which will rotate us around in a circle. So every frame that this timeline gets called, it's going to update, and it's going to run through these, then it's going to finish, it's going to play it again. So if we save that, we go back to our map. One way that we can quickly look at this is on the drop down on the play button, so we can just simulate. and you'll see that this is now bobbing up and down. So that's a really quick way of making animations using timelines. The next thing that we said we'd do is create an animation every time that you touch one of these health pickups. So that's going to happen inside the UMG element on the health bar. The health bar is going to scale down and then it's going to scale up again. So to do this, on the bottom left, I've created an animation here called HB Animation. And if I play that, you'll see it just does a little bounce. So I'll delete this one and I'll start it from scratch. So the idea is, you create the animation and you name it. So this is the health bar anim. And on the element selected, if we scroll down, you'll see various little keyframe options all the way up and down this. So inside the transform options, once we click that health bar animations, these will all become active, and we can set a key for that scale. And you'll see that down here on the timeline. Now that's created that at 0.5 seconds. What we're going to do is create another one at 0 seconds, and in between these two frames, we're going to be bouncing up and down in the animation. So the first thing we want to do is shrink a little. So we'll go to 0.9, press the keyframe button, and then we're going to scale up to 1.1. We'll hit the keyframe button again, and now when we press play, we'll see this little bounce animation. In order to play this, we'll have to go back to the graph, and in our set health function, any time that this outputted health is different from a previously cached health, we'll make that animation play. So to do that, we'll need to promote this into a variable, and we'll call that last health. We want to set that at the very end, so that every time that this function is run through at the end, it saves that last health. Before we save that, we want a branch. It's going to ask a question of, is this calculation equal to the last health that we stored? So if we drag off that pin, double tap equals, and click on equals float, we'll drag that last health in. So if this is true, we don't want to do anything, so we'll just save it. Now if this is false and last health is not equal to current health, what we're going to do is we're going to play our animation. In order to play our animation, we can drag it from the left hand side underneath animations in the variables, so this is where they'll all show up for every animation that you create. And we can just type play animation on that. So we'll pull the false pin into this animation, and there we go. We'll play the animation, we'll save that health, and it'll do the same thing next time. So if we save that now, we'll just move it out of the way. We'll click play in the selected viewport. Every time we touch one of these, we have a nice little animation happening. The last thing that I want to show you guys is a simple lift blueprint, which is customizable. It was created by Zach Parrish in an Unreal Engine tutorial video. You can go and watch that in a link in the description. We're going to do that same tutorial really quickly here. I've gone and created a lift platform, similar to how we made the other sprites. So because I've got that lift platform, I'll be able to make a blueprint. If we make an actor, and we call it lift, go straight in, create a new scene route, we'll add a new sprite, and that sprite's going to be our lift. So there he is. Next thing we need to do is make sure that he has collision. So if we look at this from the front viewport, we'll be able to change the boundaries of this to be equal to our sprite. So if we save that, we'll also make sure that the paper sprite's parent is that box. So now whenever we move this box, we'll be moving the sprite with it. In the event graph, one of the things that we can create is a variable that's editable inside the scene view. So this is going to be a vector, and it's going to be called the target location. So if I change the type of this to vector on the right hand side, we'll make it editable, and we'll show a 3D widget. If I compile that, go back to our map, and we'll see the target location node just there. But because it's inside the object, it's quite hard to get hold of. Go back to our lift, and we'll set this to a default of 200. So you'll see this is up in the air now. Every time we drag in one of these new platforms, we'll have this easy to get hold of target location. So what we're going to do for this animation is we're going to use a timeline again, and this is going to be our interpolation. So inside the curve here, we'll simply create a float. We'll call this lerp. So this means linear interpolation. We'll be moving from A to B based on this curve. So at 0 seconds, we'll be at 0, and at 1 second, we'll be at a full 1 value. Now linear interpolation happens on a scale from 0 to 1, which is false and true basically. And another thing that we can do for this is make sure that this is nice and smooth. So we'll set our timeline length to 1 second over here and save that. So now that we have this lerp value, what we can do is we can do a vector interpolation just by typing vector lerp there. We're going to move our box, which is childed to our root. We're going to change the relative location from where it currently is at 0, 0, 0, and we're going to move it to our target location over the value of the float that we created. So if I drag that box in now, we'll rename that to sprite parent. We're going to set the relative location of this to that new vector that we've created. We'll call that on update. The two things that we want to do is play it forward and backward. So when it reaches the end, it's going to lerp back to the origin, and then it's going to move forward again. You can have different functionality in your own game, where you might want to press a button or pull a lever to activate a lift, or it activates when you stand on it. But for this example, we're going to have two custom events, one for forward and one for backward, and we're just going to ping pong between them. So what we'll do is we'll play from wherever we are, and we'll reverse from wherever we are. And one of the first things that we're going to do is play this from the beginning. And when it's finished, we can switch off the direction, similar to the enum character states that we created previously. So when it's finished, we'll switch. If we were going forwards, we want to play it backwards. If we were going backwards, we want to play it forwards. So one of the errors that Zach Parrish found when he created this was the fact that when a player is stood underneath the platform, it does sort of clip through him. So we'll go ahead and fix this straight away before we even get in there. So what we're going to need inside the viewport is a new collider just underneath to say that when this comes down and hits us on the head, it's just going to bounce back and go the other way. So let's create that box. We'll use the front viewport again to change the size. The next thing we need to do is make sure that the collision on these is set up correctly. So they're currently set to block all dynamic, but because our player is default set to overlap everything, that's not going to work. So if we go to collision presets, custom, it'll open up the options for us. So our player is going to be blocked by the main collider. So on the trigger, what we want to happen is that this only interacts with the player. So if we make this custom, we ignore everything except we overlap with the player, what that means is that we can create an on-component begin overlap, which will only ever happen when the player is touching it. So that saves us from casting to it. Casting can sometimes be process heavy, so the less of those you do, the better sometimes. Next thing we want to do is branch based on the direction that the platform is moving. We can drag our interpolation timeline, and we can ask it if it's reversing. And if it is, that's when we want to move the other way. Then we simply want to tell it to play forward. One of the other things that Zach Parrish did was change the duration of this interpolation. Because it's happening from 0 to 1 over 1 second, we can just change the speed at which this plays. So we'll create a duration float, we'll make that editable so that inside the editor we can change the lift's duration. And by default, we'll make that 3 seconds long. And in the event begin play, if we drag our timeline in, we can set the play rate. So we're going to set this at a value of 1 divided by our duration. And we're going to play it from the beginning. If we go into our map now, we'll see that duration is an option on the right hand side, when I can change that to 2.5 if I like. So if I click on play now, we'll be able to go towards our platform. We should be able to stand just underneath it, and it won't hit us on the head. But one of the things that we can notice is that we didn't know exactly where that was going to end up. So another thing that we can do based on the tutorial from Unreal is set up a new construction script like we did previously with our health and damage pickup. So what we're going to do is create a boolean which is editable inside the scene view, and we'll call this B is at end. So if we take our sprite parent inside this construction script, we're going to be setting the relative location of it to be equal to either the origin or our target location. And to do that, we can drag off of this vector and type select vector. That lets us pick from A or B based on a boolean. So we'll take that boolean, we'll also make sure it's editable so we can see it inside the scene view. And using that select vector, if is at end is true, then we're going to pick A, so we're at the end there using the target location. Otherwise we'll be where we were originally. So if we go to our map, this allows us to basically line things up really nicely. So my platform's now sat on the surface there, and if I click that tick box, you'll see that it's a little bit too high. So I'll move this down, and there we have it. So if we go ahead and hit simulate, we'll be able to see that this is no longer clipping through the world. So that pretty much does it for a couple of simple animations. Next episode we're going to create a level changer, which is kind of going to end the tutorial series for gameplay mechanics. So thanks very much, go ahead and make some cool animations, and see you next time.